All right, I think I'm going to go ahead and get started. Thank you guys for coming out on the first session of the second day to learn about some TypeScript. I'm going to talk about how I've used TypeScript in more of an enterprise environment to build a JavaScript-based app, and I'm going to give some of the pros and cons along the way. First of all, who am I? I'm a developer from Minneapolis, Minnesota, so this fine area. I've been building web applications for pretty much all my career. Used a variety of different back-end languages and a variety of front-end languages as well. I kind of started out building a lot of stuff with JavaScript, particularly Angular apps, and ran into some things that I didn't care for, and that kind of led me to investigate TypeScript. So what we're going to cover here in this session today is what TypeScript is, what the syntax is. We're going to show you how to get started, how to get up and running using it. We're going to talk about what makes it a good enterprise fit. Since that's the topic, I got to talk about a little bit of what I think an enterprise means. We'll talk about how you can easily use any existing JavaScript library with TypeScript. It's one of the unique things about TypeScript compared to the other transpiled languages out there. We'll show some of the tooling, which I think is another sweet spot with TypeScript. And that's both on the editor and IDE side, as well as some of the build tools and the library management tools. And then finally, I left some time at the end to take any questions that you guys have. And if there's something that you want clarification on during the presentation, just feel free to raise your hand and be happy to stop and answer it. All right, so we'll start out with what is TypeScript? TypeScript is really a tool that lets you write JavaScript the way you really want to. TypeScript is a superset of JavaScript. So it's some syntax added on top of the JavaScript syntax that we're all probably already used to. And everything compiles down to just plain old, very readable, actually, JavaScript. And we'll see examples of that. You can use TypeScript with any browser, any host. It's open source. And believe it or not, Microsoft made this product. I know, it's a little bit hard to believe. TypeScriptLang.org, they have a very nice website, a lot of tutorials to help you get started, a lot of helpful information about the language and the tooling. Well, wait a second. Microsoft and open source, pigs must be flying, because this is not your dad's Microsoft, as I've heard people talk about. It's really pretty surprising to see the transformation that even Microsoft's gone through. I think clearly they were getting their business handed to them by all the other open source frameworks and tools out there. And just in the last, I'd say, couple years, there's been a dramatic shift that I've observed in all of their developer tooling and kind of their philosophy when they make new products. And, you know, they're not 100% open source, but most, if not all, of their developer libraries, those kinds of things, they've moved to open source. And TypeScript was kind of leading the way. It was one of the first things that they did using that mindset. So you got to be, I'm skeptical always when you mention Microsoft. You have to be. But it's been amazing to see their transformation. And they do run it as an open source project. You can go out there. It's on GitHub. You can contribute to it. And I think it's really helped get folks to actually adopt TypeScript. So if you don't remember anything else from this presentation, remember this. JavaScript is valid TypeScript. So on the left-hand side of the slide here, you'll see some TypeScript code. And on the right-hand side, you'll see the JavaScript code that the TypeScript compiler spits out. And they have this cool tool on the TypeScript website where you can do this. You can type in some TypeScript and it'll show you the JavaScript right in the browser window. And if you look at these, you'll notice in this example they're exactly the same. And you know, again, if you're using just plain old JavaScript, take some out of a JavaScript file, paste it into a TypeScript file, and run the TypeScript compiler, it's going to spit out the exact same code. So, and you could do this because TypeScript is a superset of JavaScript. So it's stuff added on top of the JavaScript language. So this next example here, we've got TypeScript again on the left, and we have the outputted JavaScript from the compiler on the right. I think this is a little bit more of a real-world example. This is code from a fantasy football draft system I wrote for my friends and I to use for our draft. And you'll probably notice that, again, very similar code between the TypeScript and the JavaScript. Now we're using classes here in TypeScript which don't exist in ECMAScript 5, which is what we're showing on the right. But you see the TypeScript compiler has gone in and put in all of the boilerplate, as I like to call it, to make a class-like structure possible in ECMAScript 6. And I did just remove a couple of extra white space lines that the TypeScript compiler put in. So other than that, I did not alter the code on the right side. Question?
Yeah. Are you going to be... So this understanding I have in my head is the sort of evolution of JavaScript in terms of ES6 versus TypeScript.
Yep.
Are they evolving separately?
Mm-hmm. Yeah. Gotcha. Great question. So his question was, how is TypeScript evolving in relation to how like ECMAScript 6 is evolving? And the answer is TypeScript has been following ECMAScript 6 along the way. So I'll kind of get to this a little later in the presentation, but basically TypeScript is a way for you to use all the ECMAScript 6 features now and transpile those down to ECMAScript 5 so that you can use it in the browsers today. And they've been following closely the spec for ECMAScript 6 so that they can match it pretty much 100%. I think they're at like, if they're not exactly at 100, they're like real close with the 1.5 release of TypeScript that just came out. So of course ECMAScript 6 I think only just recently finalized. May even have a new name, JavaScript 2015 or something. So they've been lockstep along the way targeting it. Great question. So features. TypeScript has classes. We kind of alluded that before. You can see that in the code example I have on the right. There's modules built into TypeScript. Again, you're going to see a lot of these features mirror what's in ECMAScript 6. Here's one that's not: interfaces. So these are optional in TypeScript, but you can, if you'd like, create interfaces. Some people like those, some don't. You can use generics with TypeScript because it provides the types. You can have the concept of generics. I've got an example of that on line 19 up there where you can see I've got an array of fantasy team objects. You can use arrow functions or closures. I don't have an example on the screen of those, but I think we'll see those a little later. There's references. I'll explain what that means in a moment. You can have type definitions. So if you have a JavaScript library that either you wrote or somebody else wrote, you can either create a definition file, or if it's a library somebody else wrote, somebody's already probably wrote the definition file to basically annotate it with the types. And we'll see more of an example of that. One of the things I like about TypeScript is I feel like the this keyword works more how I'd expect it to work, coming from other object-oriented languages. So I like that feature. So let's talk about some pros and cons. Because there's always advantages and disadvantages whenever you look at a new tool. Some of the pros, I think, for TypeScript are that your syntax is really JavaScript plus some optional type information. So you're not learning a new language or a new syntax like you are with CoffeeScript or Dart or some of the other transpiled languages out there. It targets ECMAScript 6, so it's following the language constructs that are going to be in ECMAScript 6. So if you want to be doing and using a lot of the ECMAScript 6 things now, you could just adopt TypeScript. Or, of course, you could use Babel or one of those other transpilers. The sweet spot for TypeScript is, of course, the optional types. And I always like to mention that they're optional. You don't have to use them. I find that I use them in most of my code, but not all of my TypeScript code will have the types in it. And I like having that flexibility to pick and choose. But you're kind of missing out, I think, a little bit of the power of TypeScript if you don't use types at all. Then you're not getting quite as much of the benefit from it. I like to be able to use things like classes, generics, and interfaces. Perhaps that's because I came from more of a object-oriented background. That's everybody in the room they may not be excited about that, but for me that was a benefit. And I kind of already talked about how it just handles this in a way that makes more sense to me. Disadvantages. It's going to introduce a compile step to your editing process. So you're going to want to set up a watcher with grunt or gulp and have it watch your TypeScript file, so when you make a change, it compiles them in the background for you. You're going to need to introduce that kind of build step to your process if you don't already have it in place. Debugging, I thought this was going to be a pain point because you've got your TypeScript file and then you end up outputting a JavaScript file. That's the thing the browser actually sees. But it turns out I flipped on the source map option in the TypeScript compiler, and I didn't think this would work, but I went into the Chrome DevTools and I set a breakpoint in my TypeScript code, and it worked. It stopped at the breakpoint, showed me my TypeScript code, the variables were there, I was blown away. I didn't think it was going to work, it worked. So check that out. Debugging hasn't been as hard as I thought. There still is that other layer with the compiler, so I had to put it down as a somewhat of a disadvantage. And then finally, TypeScript is another language or tool that you would be introducing to your team or your company. So with that, you've got to educate the other developers. You've got to incorporate it into your flow. It's just something to be aware of. It's somewhat of a drawback of using a tool like TypeScript because it's just another thing to learn. I think it's very easy to learn and adopt, but it is another thing. So I mentioned the bad E word at the beginning that I was going to talk about enterprise. And when I think of enterprise apps, these are some of the characteristics or situations that come to mind. You have greater than 2 developers working on a project or a team at one time. So instead of having just one person that just kind of knows the whole code base and they're responsible for making all the changes, now you got to collaborate with a team. And I think TypeScript is really helpful in this respect because you've got more structure to the code just automatically for the most part. Unless you're not using any of the class constructs and any of the structural things that TypeScript and ECMAScript 6 give you, you're really giving some more structure to your code. And I think it makes it easier in a team environment for other members of the team to jump in and understand and navigate the code base. And typically on enterprise teams or teams in general, you're going to have a mix of junior developers and senior developers or folks that are new to JavaScript. Maybe they've been working more on the back end of the system before. And I think TypeScript is particularly beneficial for those folks because they may not understand that there's a book written about JavaScript, the good parts, that's 120 pages long and that's it. They may use parts of the language that you would rather they not use. And it takes some discipline in JavaScript to write well-structured code. You've got to understand the prototypical inheritance and some of those things. And TypeScript abstracts all of that away so that those junior developers, you can say, hey, I want you to write a TypeScript class. Here are standards for doing that. They don't have to worry about all the nuances of how that gets translated to JavaScript. So they can be productive and be producing better code quicker. When you have larger code bases, having the structure that TypeScript gives you, I think, is also hugely beneficial. It gives you the ability to do things like refactor your code, so you can change the name of methods, classes in your code, and the compiler is going to help flag spots where it needs to be updated. And you're going to catch all of the places that an update needs to be applied a lot quicker than you might on a JavaScript project because you've got that structure. In an enterprise environment, you also need to leverage existing code that may have come from other teams, other companies. And TypeScript actually helps here by giving you the ability to write what's called a type definition file. You can think of it kind of like writing an interface in a language like Java or C#. You're just really saying, here are the types that are part of this JavaScript API. Here's the return type. Here are the methods. And they're real easy to write. These definition files exist for almost any third-party JavaScript library out there already, so you might not have to write a definition file unless it's some internal company library. And even then, they're optional. You don't have to have them, but they'll help you out with the TypeScript compiler. So I think TypeScript helps you leverage the code from the outside, helps you understand it and work with it as a result. I think enterprise also, they value proven technology and maybe a little bit more stable than being on the bleeding edge. I like to say they don't mind being on the cutting edge, but they probably don't want to be on the bleeding edge. And every enterprise is different. Some are more conservative than others. But I think for the most part, they value proven technology a little bit more. And TypeScript's now been around for a few years. It's not necessarily a new language or a new platform. A lot of people are probably hearing about it for the first time, but it's actually been around for a while. There's a track record now. You can see how Microsoft's evolving it over time, and I think you can be more confident adopting it when you take a look at that history. And then finally, I think the enterprises value productivity. They want to give, they want their developers to use tools that make them productive so that you can get more work done. And I think TypeScript helps out in this area by leveraging the different toolings that are out there in the different editors and IDEs to, again, help you with refactoring, help you understand the structure of the code. I think these are things that make us more productive. And just giving that structure to all the developers on your team can help, again, reduce some of the bugs and increase some of the productivity. So we kind of covered some of these points already about why you'd want types. So types are one of the unique things that TypeScript provides. You won't see types in, if you use something like Babel, that's another transpiler that takes ECMAScript 6 and compiles it to ECMAScript 5. Let's say you won't have types in there. Types aren't part of ECMAScript 6. But there are some benefits to them. You may or may not be aware of some of them. Certainly they add extra information that you're putting in the code, and some folks don't like that. That's understandable. But they do give a lot of structure if you have a large code base or a larger team. We kind of mentioned that already. They help you catch errors early. So the compiler is going to run, and it's going to tell you if you're passing something to a method that you shouldn't be. So if you're passing a string and you're supposed to pass an integer, it's going to let you know that right away at compile time versus when you ran your test, assuming you wrote a test, or when you're actually in the browser using the app. You're going to get notified at the compiler level. That means you catch the error quicker. You can put the fix in place, and no one ever even sees you made the boo-boo. The types also help you provide a structured API. So you can spit out documentation from your TypeScript classes that all your other teammates can see and use so that they know what methods they can call on your code, what argument types are involved, both as arguments and return types. And so there's some structure there to the code that hopefully makes it easy for others on your team to jump in and understand what's happening. And then finally, the tooling, as a result of the type information, can provide a lot better code completion and refactoring. And I found this helpful when I was learning a new JavaScript library. I was learning how to build Angular apps, and you don't have to call a lot of Angular methods, but when you do, it's really helpful for the editor or IDE to give you a nice drop-down list of what the different things you can call on, let's say, the log service in AngularJS. Because everybody does logging a little differently, and it was nice to just get that drop-down and know I could call the debug method and pass in a message and an object. And I didn't have to go look that up in the AngularJS documentation. I got it right in my editor and my IDE. So what about existing JavaScript libraries? It turns out that there's a GitHub project called Definitely Typed, and it provides TypeScript definition files for tons of JavaScript libraries. Definitely all the major ones are well covered on there. I'm going to show an example on the next slide of how you can write your own custom definitions. So if you had an in-house JavaScript library and you wanted to have a definition file for it that would give you all the type information, you can write one of those. And so we'll show that in a second. And then finally, there's a tool called TSD that you can get through NPM. And TSD is the TypeScript Definition Manager. So if any of you are familiar with Bower and how it manages your client-side dependencies, it'll go out and grab the JavaScript library for you and stick it in a directory in your project. TSD will do that for the TypeScript definition files. So it will go out and grab the definition file for, let's say, Angular from the Definitely Typed GitHub repository and install that for you in your project. And not only will it grab Angular, but it'll grab any dependent libraries that the Angular definition depends on. So it turns out the Angular definition actually depends on the jQuery definition, since there's kind of a light version of jQuery patch that comes with Angular. So you can, they've packaged the definition files together. So TSD will handle all that for you, so you don't have to know that. It will pull both of them down so that you can just reference the Angular one and be done. So let's take a look at one of these custom definitions. So I needed to use a JavaScript library that Pusher, which is a service that does real-time notifications, uses. So they had a JavaScript library that I was using, pretty simple. You can see how I was using the Pusher library in the code sample below, particularly lines 184 through 104 through 106. So I needed to use this JavaScript library, but it didn't have a definition at the time. This is a couple years ago, probably has one by now. So I decided to take the opportunity to write my own. So I created a pusher.d.ts file. So the .d just stands for that it's a definition file. So you're not going to have any actual code statements in there. You're just going to have code that describes the interface, the methods, the classes that are involved with the library. And so in my case, I had two classes that I was using, the pusher class and the channel class. And so for the pusher class, I identified that it has a constructor that takes a key. The key is something that's unique to your account with Pusher. And then has a subscribe method that takes in a channel name string and returns a channel. And then I had the interface channel, which provides the bind method, which takes in an event name that's a string and a callback function. And so I just defined that in my pusher.d.ts file, included that in my references TypeScript file, which I'll show in a second, had all my library references in it. And then I was able to use it, as you can see in the code sample down below. So I was able to just say, hey, give me a new pusher instance, and I was able to call the subscribe method. And then in the channel, I was able to call the bind method. And so the TypeScript compiler then knew about my methods and my arguments, and it could tell me whether or not I did things correctly, at least as far as it knew from the definition. So this is pretty easy to write. Took me, I don't know, half hour to figure out. Most of that was figuring out what are the pusher methods I'm going to need. Question?
Yeah, sorry, really basic question, but if we're writing our own types, do we, or our own libraries, do we need to create separate definition files, or is that only in the case of existing?
Right. Okay. Yep. So the question is, if you were writing your own library, would you need to write this definition file? And the answer would be no if you're writing it in TypeScript. So if you're writing code in TypeScript, you don't have to write the definition file because the definition's right in the code. If you are writing or using a JavaScript library, that's when you might want to create one of these definition files. You don't have to, because again, you can just use the any type in TypeScript. You wouldn't have to type it, and you could still call all of the JavaScript code. You just wouldn't get the benefits of having the types checked by the compiler. Good. I think there's another question. Yep.
Usage is cut off that you got.
Oh, right here? Yeah, so I highlighted kind of a part of a method. You're right. I don't, I'm not showing all the other stuff that's happening below.
That's the definition up there.
Yeah, so the top is the definition. That's your pusher.d.ts file. It's 8 lines. That's all it is. And then down below is where I actually am using the pusher API inside my Angular app. But it's just a small snippet of that. Yes?
That, the chat interface, you're saying the callback to the function. Is there a way for you to specify like the types of arguments?
Oh, that's a great question. Yes, I believe there is. It has to do with what's called arrow functions in TypeScript. I'm probably not going to have a chance to show a full example of that. But yeah, you can go in and you can identify for the TypeScript compiler what things are required inside that callback. So you're right. I could have provided more information than just saying, hey, it's a callback function. And I probably should have, right? I probably should have put in as much information as I could. Question over here.
Is there something out there that might take a normal JavaScript file and try to generate the definition based on a best guess to get you started?
Yeah. I don't know. If you look at the Definitely Typed project, if anybody had it, it would be them. They might have some tool in there that'll take a look and try to figure out some things. I think at best it would only get you maybe 50% of the way there, what it could infer, maybe more. But I think what I've seen like with the Angular project is it looks like somebody goes through and kind of checks and really does make sure that the definition file makes sense and is what a programmer would expect. So I don't know if anybody's doing it in an automated way. It's an interesting question. Yep.
So if I had a JavaScript file .js, right, I could probably just change it to TS.
Yes.
TypeScript.
That's right.
If I compile that thing though.
Yep.
It doesn't have its
Right.
It's fine, right?
Right. You won't have any types. So in that case, what I'd recommend you do is just keep it as a JavaScript file, right? So don't change the file extension. Don't worry about compiling it. But just write yourself a custom definition that outlines what methods are in that library, what the return types are, and then reference your definition in your TypeScript code.
But what is it compiling?
Yeah, okay. So great question. So the question was, what does the compiler do with these definition files? The compiler doesn't spit out any JavaScript based on the definition file. All it does is uses the definition file as metadata so that it knows what types and what methods are possible to be called with that API. So think of it as metadata.
Actually,
Yep.
the question was for my
Okay. Yep.
JavaScript file that just renamed TS,
Right.
and then I compiled it.
Yep.
It doesn't have classes in it.
Right. Right.
What is it really compiling
Right.
in that JavaScript
Yeah.
file?
So in that case, if you take your I'm just repeating the question for the camera. So you're taking your JavaScript code and you're just renaming it as a TypeScript file, you're not really getting much benefit from the compiler. You're right. It's not going to do anything there. You're not going to get a lot of benefit. The benefit comes when you start putting in some of the types or you use some of the ECMAScript 6 features. Then you're going to get something out of that compile step. But I like to let people know that you can do that so that they understand that writing TypeScript isn't a whole new endeavor. It's as simple as taking your existing JavaScript code and putting in a TS file and then start to make some TypeScript specific changes, which are pretty minor. That's why I say that. Yep. Mm-hmm. Yep. Mm-hmm. Well, you wouldn't have any type references in there, right? Because it's just an existing JavaScript file. So the compiler would just say, oh, okay, they don't have any types, that's fine. And it would go on, continue on its merry way. And it wouldn't really be able to highlight any errors for you because there are no types there for it to check. So it's going to happily work just like it was working before. Yeah. Yeah, great question. So the question was, does the TypeScript compiler have knowledge of some of the built-in methods, like with the DOM and with strings and stuff in general? And the answer is yes, it does. There's actually a definition file that the compiler has built into it that has all the common methods for strings and integers and stuff that you'd use right in the browser. So yeah, that stuff is built in, and it will alert you if you pass something wrong into those methods. So that's kind of a nice, handy feature.
I've got another question.
Yep. Yeah.
If I just take a regular JavaScript file, I've got a function foo that takes 2 arguments,
Mm-hmm.
and then I call it with 4 arguments.
Ah.
1 argument somewhere else. Then am I going to get benefit from that file?
Mm-hmm. Yeah. So I think the TypeScript compiler would give you a warning, not an error, so it's not going to stop compiling, but it'll warn you and say, hey, you called this function with some extra arguments. You might want to take a look at that. Yeah. Yep. All right. So let's say you were interested in getting started with TypeScript. How would you go about doing that? You'd hop out to the command line, use npm to install TypeScript. I think it makes sense to install it globally at first because that'll pull down the TypeScript compiler. And then you can also add a reference to it in your project so that other folks see that it needs to be installed. And then you can use tsc. That command is the TypeScript compiler. When I'm debugging and building my apps, I like to turn on the source map option so that if I need to do debugging in the browser, I can. And then I like to take all of my TypeScript files, and get them compiled down into one JavaScript file. Think of this like the bundling step of your JavaScript build process. I just like to have the TypeScript compiler do that while it's at it. And then I usually create myself a underscore references, or in this case, an underscore all.ts file. And we'll see what that looks like in a second. But basically, it just has a reference in there to all of my library definitions, so all of my type definition files, and then all of my different TypeScript files that I want to have compiled. So, and you can have a grunt or a gulp task to manage that all.ts file for you. So it'll just notice anytime you create a new TypeScript file or add a definition, and it'll build the file for you. So it kind of manages that. It's kind of like the class path if you've used Java before. I don't know what the equivalent would be on the .NET side. And in the most recent TSC compiler that was just released, version 1.5, you can actually create a config file. It's called .tsconfig, and you can put your different TypeScript file references in there. I haven't got a chance to create that file yet for my project, so I don't have a good example to show you, but there's documentation right on the TypeScript site if you want to do it that way. So now some other tooling. You can use grunt or gulp to compile your TypeScript. They both have plugins, libraries that you can use with them that will run the TypeScript compiler for you with a watcher. This is what I use in my code. I'll show an example in a minute. And I just turn on the watcher, and then I just edit away in my TypeScript files. And as I'm saving them, the compiler is running behind the scenes, and it's keeping my application.javascript file up to date, so I can just hit refresh in the browser, and I have all the latest changes. We mentioned TSD a little bit already. Here's an example of how you would use the TSD tool to download the type definitions for Angular, including all of its dependencies. So that command there will grab the Angular definitions, any libraries it depends on. It'll write the fact that you're depending on Angular to a config file, a TSD config file. And then the overwrite command just means overwrite any existing definition files in there. So in other words, grab the latest Angular definition and throw it in my typing folder. So this is really nice so that you can stay up to date on the definition files as new versions come out. And you can target different versions. You can say, TSD, I want the Angular definition for version 1.3, instead of the latest, which is 1.4. IDEs, most of them have pretty good TypeScript support. WebStorm and IntelliJ are probably the best TypeScript editors that I've used. They offer the most features in terms of refactoring, code completion, IntelliSense, fantastic support. A surprising close second is this tool called Visual Studio Code. Yes, Microsoft has made an editor that's cross-platform, Mac, Windows, and Linux, and it's free. And it is probably the second best TypeScript editor you can get. And with it being cross-platform and free, I think it's a pretty attractive option. Obviously, there's support in Visual Studio 2012 and greater for TypeScript. Since it's a Microsoft tool, you kind of expect that. And then I've heard, although I haven't used the Eclipse plugin, apparently there's a Eclipse plugin for TypeScript as well. And then finally, a lot of the editors out there have pretty good TypeScript support. There's a good Sublime package, and then there's a real good Atom TypeScript plugin as well that's also very good. Although I've just been able to do a lot more with Visual Studio Code than I have with Atom, I do enjoy using the Atom editor quite a bit. So let's take a quick look and see what some of these tools look like in the real world. All right. All right, so this is IntelliJ or WebStorm. They both operate the same. On the left-hand side of the screen, I have a fantasy team service, and its job is to go out and talk to a remote API and download all the fantasy football teams from my friends and I. And then on the right-hand side, just for the heck of it, I pulled up the application-all JavaScript file. This is the output of the TypeScript compiler for my app. And you can see here's the actual JavaScript code right here that represents this fantasy team service over here on the left. And then down on the bottom of my screen, I have running a grunt task, a watcher, that's watching all my TypeScript files so that when I make a change, it outputs the JavaScript right away for me. And so I'm just going to go ahead and add in a change here to my TypeScript. I'm going to make a call out to the AngularJS debugger. I hit save. You can see it's noticed that the TypeScript file changed. The watcher went out and executed the task, and the TypeScript compiler succeeded without errors. And you can see it's pretty quick. It usually takes I think, well, 1.8 seconds to do the compile. And then over here, I've got my application-all file, and for some reason in IntelliJ, I have to hit synchronize sometimes for the changes to show up. So there you can see there's my log services in the JavaScript now. So it's that easy. Here's my grunt file. It's pretty easy. I'm not using any kind of special TypeScript plugin in this case. I'm just having grunt go ahead and call the TSE compiler itself. And then I just have a watcher configured to look for all the TypeScript files in a particular folder. So pretty straightforward to set those up. There's a lot of community files you can go grab if you use grunt or gulp. You can just grab somebody else's grunt or gulp file and use that, and it'll set up the watcher for you. So that's kind of nice. One of the other things I was going to show is in my editor, I've got my log service. This is the AngularJS log service, and I've provided the type right here to my editor. So when I go down here in my code, it'll let me know what types of things I can reference, and then it'll tell me what the different methods are I can call. And so along the way, it's giving me nice hints in terms of what things I can actually call along the way. Including what variables I have, highlighting that I was missing that. And you can see here, I created an error. So I don't have a variable named date, I have a variable named data. And so the editor right away in real time is telling me, hey, you got a problem here. And I can either have the editor create the date variable for me, or since it's highlighted in red, and you can see down here, the compile failed, and it should give me an error right here. I can go, oh, okay, I'm going to go change that. That was silly of me. And this should be, yeah, data. That's what I want. And then I can hit save. And you can see here, now I've compiled without errors. So a lot of nice editor support. I can do fun things like I can go in here and I can say I want to refactor this and rename it to save team number 2. Hit refactor, and it'll go through my whole project and change any references to that method for me. This might be a little harder to see. This is Visual Studio Code. And here I've got another TypeScript app that I found out on GitHub. And you can see here I can navigate to some of the different classes that are involved. You can see how promises are indicated. And I can even go through my repository here. I don't actually have a good example in Visual Studio Code right now, but you can do code navigation. Again, you can do refactoring. You can find all the references. I can rename that method to a different name, and again, Visual Studio Code will go through and rename all the references to that method. So some helpful little tools. And what I like about Visual Studio Code is it's free. It's got a built-in Git client, which surprisingly even Atom, which is made by GitHub, doesn't have. So I kind of like it. It's a nice little tool that's cross-platform. All right. Let's head back here. So the app I was working on, the fantasy football app, what I did is I actually originally built that app using JavaScript. That's all I knew at the time. And then I learned about TypeScript, and I thought, oh, I'm going to take this app that I built in JavaScript and Angular, and I'm going to move it over and build it in TypeScript. And along the way, I added types, obviously, to the code, since that's something that TypeScript provides. And I found that my code just had a lot better structure in the end. I was able to actually use classes. I had methods with return types and arguments, and it was just easier to navigate through my code. And then probably the biggest benefit for me at the time was it helped me learn Angular's APIs. I had a lot easier time knowing what I could do with the log service, how I could use their HTTP service to make REST calls. Suddenly I could tell what methods and arguments I needed to pass in versus having to have like 20 browser tabs open to all the different areas of the Angular documentation. It was just a much nicer, more productive experience by leveraging the tooling. So that was a nice benefit that I got to see in the real world. And I've seen those things with our projects at my day job too. I'm not able to show you that code. So just to take a quick look at the app I built, because some folks are usually interested to see that. See if it's actually still up and running and working here. Here's the draft system, and you can see I've got different positions you can filter by, and this is all AngularJS app. You can look at who the current person is who's on the clock, and then you can go ahead and make a pick, enter a pick for that person. And you'll see in real time it updates, and this actually will go out to any other browsers that were connected using the pusher library and let them know a pick was just entered and shows who was just picked and the time since that last pick. So it's just kind of a fun little app. It was a lot of fun to actually rebuild that in TypeScript. Okay. So just to review a few key points, JavaScript is valid TypeScript. So remember, that was the one thing if you get out of this presentation. TypeScript's following the ECMAScript 6 standard, so you can use all the nice ECMAScript 6 things now, and the TypeScript compiler will output ES5 for you that you can use in all the browsers today. So that's kind of nice. Types are optional, so there's definitely areas in my TypeScript code where I just will say any, or I'll just have no return type specified. So use them where they give you value, where they help you. TypeScript doesn't force you to use interfaces or to even use classes. There's a lot of situations where I just want to pass a method around or use callbacks. You can use the arrow function syntax in TypeScript. You can totally do that. You don't have to have everything be a class. You don't have to have everything be an interface. I don't even think in the apps we've been working on, even at work, I don't even think we've built out any interfaces. You know, we definitely use classes, but we haven't really found a need to define a lot of interfaces, really any. And then just love the refactoring and tooling support. That's been the biggest benefit of using TypeScript is just getting all the code completion in the IntelliSense, and you do get a little addicted to it. But I think it helps make me more productive, especially the refactoring tools. And the structure that it provides for particularly some of the developers that I work with that aren't used to writing JavaScript, just a lot less errors and stuff that we've had to deal with those folks, because they've got the structure, and TypeScript handles all that boilerplate JavaScript code for us. I've got links here in the presentation, which I'll have up on the GitHub repo for Midwest.js. A couple of links to some real-world, larger TypeScript-based apps that I've found. There's an Angular in 20 minutes example app where he builds out a real-world Angular app, apparently in about 20 minutes. But it's really interesting to go and see how he used TypeScript to build the Angular app. And you can get some real-world usage of TypeScript and how somebody's benefited from it. There's also an expense manager app that you can look at too. That one's even more detailed than the 20-minute one. Both of them have nice grunt and gulp scripts that handle all the compilations. You can see how they did that. They're just really good examples that let you learn not just about TypeScript, but also about how Angular works and best practices there. I've got some references too for some articles talking about TypeScript and some of the benefits that it provides. You can look at those on your own. And then I left time at the end just if folks have some additional questions for me, or if there's something else you'd like me to demo, I can certainly try to give it a shot up here. And then I just want to remind folks to fill out the feedback form. If you haven't already, you can go in and give feedback to all the speakers, and definitely encourage you to give me some feedback on this presentation. So cool. So with that, I'll take questions anybody has. You guys have been great about asking questions along the way, so there might not be a lot of them.
Yeah.
Yep. Right. So the question is around TypeScript and Angular 2. So Angular 2 is being written in TypeScript. However, to build an Angular 2 app, you don't need to write your code in TypeScript. That's my understanding.
That's correct.
Good. Yep. I think you get some benefits probably out of writing your Angular 2 app in TypeScript. They have the annotations, the stuff in square brackets that they're using a lot in the Angular 2 examples that I've seen. And I don't know, there's another way to do those annotations, probably with comments and some kind of compiler. Or perhaps there's a way in ECMAScript 6 to do it. But I think what the impression I'm sort of getting, and maybe this is wrong, is that they're probably going to recommend that folks consider using TypeScript to build their Angular 2 apps because it's probably going to feel a little bit more natural. And I've seen a lot of interest in TypeScript increase because Angular 2 has decided to be written in TypeScript. Does that answer your question? Great. Yep. Oh, yeah. I have not a lot. I've definitely heard about it. I've heard that what they do is they have, I believe they use code comments to provide hinting for the types in their JavaScript. Maybe I'm wrong about this, but what's that? Inline, okay. Yeah, and so and then do they have a compiler? Do they? Yeah, I'm not sure either. What the impression I got before is that they had some type of metadata approach where they were annotating somehow in the code what the types were, and then they had tooling that knew how to read those annotations. And so it seems like an okay approach, but I kind of like TypeScript's approach a little bit better because they're just saying, look, we've added some stuff to the language to define the types. And so since they bundle a compiler and language service for the IDEs, I think you're just going to see a lot more tooling on the TypeScript side. It's just so much more built in. So I see what they're doing, and I think they use it a lot to annotate their existing JavaScript code, but they probably started before TypeScript was around, or didn't want to use TypeScript for whatever reason. So they're accomplishing a lot of the same things. I don't think you can use like ECMAScript 6 features with it, though. I think you still need to follow the regular JavaScript 5, let's say, constructs, right? You can't use classes and stuff like that unless you're using ECMAScript 6 with Flow. And then I don't know if it compiles it down to ECMAScript 5 for most of the real-world browsers. Okay, so 2 questions. Do I know of any plans for the browsers to support TypeScript? No, and I don't think they need to. So I don't think there's any plans to do like what Dart was trying to do, where they were trying to build a Dart VM and bundle that in the browsers. I don't think there's any plans to do that for TypeScript. TypeScript's model is to take TypeScript code and transpile it to regular JavaScript. And you can target ECMAScript 5 or ECMAScript 6. And I'm sure when ECMAScript 7 comes out, they'll add that to the TypeScript compiler. Great questions. Yep, so classes can inherit other classes, absolutely. It kind of follows your typical inheritance structure. I don't believe you can extend multiple classes. You can implement multiple interfaces, but you can only extend one class. But yeah, you can do the whole inheritance hierarchy if you like, and you'll see those in the different example TypeScript apps that I had in the code. You'll see them do that at times. And then you'll also see it if you look through the definition file. So if you look at like the Angular TypeScript definition file, you can see how they've set up the types and they've set up inheritance in some cases, if that's really what the Angular code is doing. So kind of interesting to see that come together. Yep. Well, it'll make sure that it's outputting valid ECMAScript 5. I don't know if that's where you're kind of getting at. So it'll make sure that it should work in that output format. So if you use some ECMAScript 6 feature in your TypeScript code, it'll make sure to translate that to the equivalent ECMAScript 5 code to make that language feature work.
I'm more saying like if I have all of my implementation in JavaScript.
Oh, okay.
Defining, adding the type of
Yeah, add some types. Okay. Yep. 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 Is it not there in the? Well, you would. So you're trying to compile a TypeScript file. Does the TypeScript file have a type defined? Are you telling it, hey, this object I'm working with is a fantasy team, or does it? Or because it's JavaScript, it doesn't have the type? Oh, I see. You're writing the definition file. I see what you're saying. Yeah. So if you had an error in your definition file, would the compiler catch that? I think, is that your question?
Yeah, right.
let's see. So the TypeScript compiler would look at your definition file. It probably wouldn't look through the actual JavaScript file. Yeah. So yeah, I don't think it would look through the actual JavaScript file. It would leave the JavaScript file alone. The only thing the compiler is going to look at is any TypeScript files and any definition files. So if you had TypeScript code that was referencing the definition and you messed that up, then it's going to flag it. But it's not going to do anything to your JavaScript. It's going to go hands off. Oh, that's a JavaScript file. I'm not going to touch that. It's okay. And it's going to rely on that definition file to know what's in that JavaScript file. Does that make sense? Then it would treat that as TypeScript. Now again, if there were no type annotations, the compiler wouldn't have a lot to go off of to check. If you either inserted those in that TypeScript file or wrote a definition file, then it could start doing checking against that. Yep, great questions. Yep.
What was your experience like getting people to learn this on your team?
It was actually easier than I thought. And I think the reason it was easier, so the question was how easy was it to get my team to adopt it? And I think it was easier than I thought because it was just a superset of JavaScript. So we had developers, they understood basic JavaScript syntax. They didn't know how to do classes and stuff in all the right JavaScript ways. So they looked at TypeScript as, oh, I just have to add some types. And in their case, they were used to working with C#, so they knew about types and objects. And so that part was really easy for them to use. One of the pain points was just the tooling. So I had to make sure that they had Grunt installed and they had the watcher installed so they were compiling all the time. So I think that was the biggest hurdle. We had to make sure that we had our IDE configured and we had our build script set up.
And what was the main selling point that got you permission to do it?
For us, it was being able to get the junior developers into the flow and get them more productive and writing better code in our JavaScript-based apps. That was the big push. We just had so many cases where they just didn't have the discipline to kind of do it the way we wanted it and structure it nicely. And we're just running into having to rework a lot of their code a lot. And it's a learning opportunity, so it's not a bad thing, but we were able to move a lot faster when we started getting them all on TypeScript. And then the other big benefit was we wanted to be able to do the refactoring. We wanted to know we could change and refactor and improve our TypeScript libraries over time and ultimately produce a better JavaScript app as a result. So those are the two big pushes. Great questions. All right, quick poll. Who's going to take a look at TypeScript after learning some more? Oh, wow, that's great. Well, thank you, guys. Hope you enjoy the rest of the conference.